We're going to be going over inputting of driller's subsurface data into the example structure project that we created in the last video. So first I'm going to open up the gINT KYTC training material that I've downloaded onto my desktop, and then I'm going to open up drilling input. And so for the example structure, I have a image of the boring locations for that example project. And so this is the New Bridge location here. And there's 6 holes. There's 2 sample and core holes here, the circles with the filled circles in the middle, and then the open circles are soundings. So we're going to be going through how to input this information. So I'm going to close that up, and then I'm going to open up the driller's logs for the example structure here. And so this is the driller's subsurface log. It has information about the hole here, about water information, start date, hole type, and then different things about what samples were taken, the soil that was encountered, information that's obtained by the drillers during drilling. So now we're going to open up the gINT file here. And so here, this is the file that was created in the last video. It has all the default values for the holes for the example structure project. So we're going to go through inputting information from the driller's subsurface logs into this gINT file. So I'm going to pull both of the driller's subsurface log and the gINT file up at the same time. We're going to go through inputting information. So we're going to start with hole 1001 here. It already has station and offset imported from the last video. And so total hole depth is in this top left corner. Total depth is 18.2. Go through. Start date is right here. An end date, 6-03-2016. The fields that are colored with this light blue color will be populated on save. So that's the intent. So if the start date is the same as the end date, that'll be populated. So getting into hole type, the hole type is located upper right corner, core and sample. Core and sample, there was no observation well installed. It was auger, hammer method was automatic, rig number was 45T. Again, this blue field here, the checkbox, if refusal depth is entered here, upon save, the checkbox will be checked. So refusal was obtained because core was started, and so refusal depth is at 5.7. Refusal lithology was sandstone, so brown sandstone. No boulders. Driller's name is Mr. Driller. There is no driller comments for this particular hole, but important to note is the driller comments is a field, should include any information on if the hole was moved, and also should include profile remarks. So for example, if you're doing a profile hole and you have comments regarding sinkholes, ponds, creeks, wet areas, springs, wells, existing landslides, that information should be input into the driller's comments. And this information should have attached the station, feature description, offset, and direction from centerline where you're at for future reference. So there's no driller's comments for this particular hole, so we'll move on. And that's all the information for that hole, so we're going to save that, and I'll show you this refusal box is checked automatically, and then the end date is input. So we're moving on to the driller's forms. There was no groundwater for this hole, and the hole, once you move over to driller's forms, the hole you're working on currently is in this yellow box at the top. There's a little drop-down menu. You can select other holes if you want to work on those. So going on to core runs, I'll zoom in a little bit here so we can get our core run information. So our top depth for the core runs started at 5.7. Run number 1. Driller recovered length is located here, the 2.4. Standard RQD length is iterated feet, and the percent is calculated here in the blue box. The percent is shown on the driller's log, so that 44% of the 2.4 feet comes out to be 1.1. And the driller's recovered length and the Kentucky RQD length is not calculated by drillers. It's calculated by the geologist, so that information should be left blank for the driller's input. So we'll move on to the next depth for our core run, which was 8.2 feet. That's run number 2. The length was 5 feet. And then the RQD length is 92% of 5 feet, which is 4.6. Moving on to our third run. So top depth is 13.2. Run number 3. Total recovered length was 4.6 feet. And then the standard RQD length is 3.5 feet. So we'll hit save. This STD and also our depths here, our bottom depth, our run length, and our driller recover percentage will be calculated. So we'll hit save. All that's calculated. You can see that information matches up with what's on the log. So we'll move on to the driller's soil description. So we'll move over to here. So the driller's soil description is coming from here above where it says begin core. So top depth, 0. The bottom depth, because it's light blue, will be calculated. So we'll go to description of our first layer, which is topsoil. Topsoil. Continue pushing tab to move over. We'll go to our next depth, which is at 0.2. And that's a medium. A medium soft. Brown. Moist. Clay. Okay, moving on to our next description, and that starts at 2.5 feet down, is highly weathered shale to clay. And that would be input here. It is preferred to use the building terms, but if your particular description you're giving isn't in those build terms, put your soil term all together in your soil term here, soil term field. And so that's the 3 layers that were encountered during drilling. And I'll save this, and information about the bottom depths was populated. So moving on to the driller rock description. So beginning of core started at 5.7 feet. So that's this layer here. So it's a brown sandstone. There. And there's a comment with interbedded shale, and the comment here will be in parentheses there. And so that's the information for our rock descriptions. There's a brown sandstone all the way down. So hit save. Moving on to our soil samples. Soil sample information is here above the begin core. So our top depth for our first sample, which was a Shelby tube, was 2.5 feet to 4.5 feet. Sample number was ST-1. Sampling method was Shelby tube. Recovered thickness was 2. And that's all we need for that particular sample. Hit save, recovered percent populated. Moving on to our standard penetration test sample. Top depth was 5 feet to 5.7 feet. SPT-1. SPT. Recovered thickness was 0.7. And this will be calculated. Our SPT numbers was 20 and 50. So for every 6 inches you have to have a blow count. That's what the SPT number 1, number 2, and number 3 mean. If within a particular 6-inch increment it reaches 50, it's considered refusal. So the gINT itself will keep track of that. So for instance, if you have this run length was 0.7 feet, so 6 inches and some change. So in that second 6-inch increment, it hit refusal. It went up to 50 blows. So for instance, it'll pitch an error if you don't have the correct number of blow counts per 6 inches. For instance, here, no value for first or second increment. So you need to include that 50. So if you get that error, you know that there's some problems with your number of blow counts per the length of your standard penetration test. So we'll hit save. Calculates our blow counts and our N value. And this N value can be changed if you need to, but you should leave it alone unless there's some reason you want it to be displayed a certain way. So that's our soil samples. Our profile holes, this isn't a profile hole, so you don't need to fill out that table. There's no jar samples. And then our driller's remarks, you can see at the bottom of this driller's log here, there's no, our driller's remarks actually are located over here, and you can see there's no driller's remarks there. So that's what we needed to input for hole 1001. So we'll move on to hole 1002. Go back to our main group, hole 1002. I'll scroll down here to 1002. So hole 1002, total hole depth was 18.2 feet. Start date was 6-3-2016, and it was a sounding. There was no observation well installed. You can see this in A. So automatic, 45T, refusal was reached at 4.2. So you can input your 4.2 feet there. And you don't have a refusal orthology for this particular hole. Driller name, Mr. Driller. There was no driller comments here. You can see there's nothing there. And that's what we need to input for that hole. So moving on to driller forms. No groundwater. There was no core runs. A driller soil description. Top depth for our driller soils description. The first one's topsoil, so 0. Soil term, topsoil. And then at 0.4, you have overburden. Save that, Going under, there's no rock descriptions, soil samples, driller remarks, no remarks. So that's it for this particular hole. So going back, so since those are the two types of holes that we're going to be input, I'm just going to be going through, I'm going to fast forward and not show inputting information for hole 1003 through 1006. And I'm going to fast forward now. Okay, now all of the information has been input for all of the holes. And so I'm just going to go over some quick highlights for some of the holes that were unique. So for instance, hole 1003, there was a driller comment for the hole saying it was moved. And so that comment is here for hole 1003. So hole moved towards 1002, estimated 5 feet due to trees. And so because this hole was moved, you want to check for 1003, hole was moved, hit save. Holes moved, but coordinates are the same as original staked. Would you like to delete the original coordinates and elevation? We're going to click no to keep the original coordinates, but we're going to decrease the horizontal and vertical accuracy. So hit no. And so now for 1003, it decreased this vertical accuracy because it's no longer at the location that it was staked for GPS coordinates. Okay. Also for hole 1004, there's an observation well. So we're going to go to driller forms, groundwater for 1004 here. So this is how information for an observation well is supposed to be recorded. So you have your date, you have your immediate reading type, which is at 20 feet, and then you have your 7-day wait, and then your static reading, which was at 18.7. And so I'll show you on the driller's subsurface log for 1004. Here, that this is how it's displayed on the driller's subsurface log. So you have your immediate water depth at 20 feet, and then your static water depth at 18.7, and you have your dates that those particular water depths were taken at. Okay, and lastly, for there's a driller remark at depth 10 feet for hole 1006. And so main group 1006 on our driller's forms, 1006 driller's remarks. This remark, the driller's remarks table, you can input your depth you want your remark to show up at, and then your specific remark. So this one says pushed Shelby tube with no recovery. So we'll go up, pull up the driller's subsurface log for hole 1006, and you can see here, push Shelby tube with no recovery at 10 feet. So this at is a formatting issue that it's input, and then the 10 feet's coming from your depth that you've included in your driller's remarks depth field here. And so that's an overview of inputting the example structure driller's subsurface data. And so now to generate the actual reports, you go to output, logs, and then you select subsurface driller's log from the pull down, and you can hit your eyeball here to preview it. And so now you have your logs generated. So that's the overview of inputting the driller's subsurface information into gINT for the example structure. Thank you very much.